And we're back solving. This time we have chapter 6.1, solving trig equations. Well, kind of what we're going to be doing now is looking at things such as the human cannonball, which is launched from a cannon with an initial velocity of 64 feet per second, an angle theta from the horizontal. So I'm just going to draw a picture just to kind of show what we're talking about here. Here's your cannon shooting a human cannonball. Here's Mr. K right here. And that's your velocity, and then there's your angle right there. Theta. Well, that initial equation, where t is the height in seconds, is right here. So that's kind of what we're going to be looking at today. So this equation involves trigonometric functions and solving equations that involve functions. Focus on this chapter, okay? So let's get moving, get you guys through this so you don't have to listen to me talk forever. Okay, we're going to do some review right away. So we're just going to basically solve for x. That's all we need to do here. So when you solve for x, you need to get all the same components on the same side or all the same parts. So first thing I want to do is I'm going to subtract 5x from both sides. And I'm going to add a 5 both sides. So that's going to leave me with 12 equals negative 3x. Well, now I need to divide by that negative 3 to get that out of there. So x is equal to negative 4. Pretty simple. Coming back in now, hopefully. Now we're going to use some trigonometry. We're going to throw a sine in there. So now we have to figure out what we need to do with that. Well, it's kind of the same thing. It's just like thinking this is my entire x, even though x is your angle, the entire thing is your x. Okay, so we need to get that by itself. So first thing we need to do is add 1 to both sides. So we have 2 sine x equals 1. Then we have sine x. If we divide, just red, a little bit of difference. Divide both sides by 2. We have sine x equals 1/2. Well, a lot of you are thinking now, oh, 1/2. Sine x equals 1/2. So that x angle, this x right here has to be an angle. So we know, okay, we're working with a triangle that we know, which sine is SOHCAHTOA, so opposite over adjacent. So this is going to be, sorry, opposite over hypotenuse, my bad. So that's going to be a 2 there. 1, 3. Well, thinking about the unit circle, we're trying to think about what this angle is. Well, knowing I have a 1, 2, square root of 3, or however you say that, this has to be a 30-degree angle. So x is equal to 30 degrees, or in radians, x is equal to pi over 6. Okay. Well, if we go around the circle again, remember we're going to be there again at k times 360 degrees, or we're going to be there at 2 times k times pi, which there's a 2 pi in there telling you you're going to hit that same exact spot if you go around the circle 1 time. Well, if you do it 2 times, you're going to hit the same exact spot. So that's kind of what we're going to be doing in this chapter right there. That's pretty straightforward. See, now we have cosine theta. We want to get cosine theta, right? Or we want to get that by itself because we're solving for that. So we have cosine theta equals, if you get cosine by itself, you only need to divide by 2. So we have cosine theta equals 1/2. Well, right away I'm thinking, okay, I just found in the last question, sine of theta when theta was 1, or sine of x when was 1/2 there, so we know we're going to use square root 3 over 2. So, which is not the same thing as this, so we know it's not going to be that 30 degrees, it's going to be the 60-degree angle. Or if you need to draw a picture, like, we know that cosine is adjacent over hypotenuse. And thinking about the unit circle, that's going to be our 60 degrees. So theta is equal to 60 degrees. And a lot of you are thinking, what about radians? Do I need that? Well, the question asks for degrees. I'm going to write that in a different color so we know. So we need degrees. Your answers should be in degrees. If I say degrees, I want degrees, okay? Now let's go to the next one. We have sine theta. 2 sine theta equals negative square root of theta, so sine theta equals negative square root of 3 over 2. Well, right away I'm going to say, okay, that looks kind of familiar. That's the negative, though, of a negative square root of 3. So we're going to be down here somewhere, which also tells me, oh, wait a minute, I did the first one not completely right. Because if you think about it, cosine is positive right there also. So what is that angle going to be? Okay, so that one's going to be, well, 60 degrees. A full circle is 360, so minus the 60. That's negative 60. So 60 degrees and 300 degrees. Okay, so we should be looking for two angles almost always, depending upon what our stipulations are. Okay, so now we know that we're looking at sine of 3 over 2, or negative 3 over 2, so we're going to have, that's a nice triangle. I'm more interested in this triangle here, this triangle here. Sorry about that. So I'm going to erase this. Okay, so now we know that this is negative square root of 3, 2, negative 1, 1, negative square root of 3, 2. Well, that means this is going to be 60. And this is 60. So now I can just say, okay, that's 60 plus 180, so that's going to be at 240. Theta equals 240, and then the other one is going to be 300. Okay, so that's kind of what we're doing. I know some of you have the ability to skip some of the steps that I was doing. Don't be afraid to do that. But like I said, if you do, make sure you understand what you are doing so you don't get messed up in the algebra. Okay, so now we want to get sine by itself in this question. So I'm going to subtract 5 sine t from both sides. Remember, if you do it to one, you have to do it to the other. So we have the square root of 3 left over, which is equal to 2 sine of t, negative 2 sine of t. And then from there, we want to get sine by itself. So we're going to divide that by a negative 2. So we have that divided by negative 2. So we have the square root of 3 over negative sine t. And then, oh, look at this. We have degrees. Or sorry, radians, my fault. Radians. So, well, thinking about this, we solved this in the previous ones. Well, we know that we have a 240 degree angle and a 300 degree angle. So t, which was the 240, if you use the unit circle or the formula to transfer back and forth from radians to degrees, we have 4 pi over 3 and 5 pi. Okay, now let's go over to the next one. that's your answer. So those are your two angles in between 0 and 2 pi. So now we want to get the sine once again, all by itself. So we have 3 sine t, and I subtract 4 equals 0. So sine t equals 0 over 3, because I divided the 3 out. So now we need to figure out where sine of t on the unit circle is 0. Well, we know sine is 0 at this point and at this point. So that is pi, 0, and 2 pi. Okay? And since we're including 2 pi and 0, those are going to be two answers. So t equals 0, pi, and 2 pi. Okay? That was a pretty quick hitter there. Let's keep on going on. Okay, the next one. We got a lot going on now. Okay, so once again, it's just a matter of getting the cosines all on the same side, or everything that can be put on the same side, then solving for that. So what I'm going to do is subtract 3 cosine theta, and 3 minus 3 cosine, or sorry, yeah, cosine theta. So I'm subtracting to get this equal 0. And then what I'm going to do is add 1, add 1. So now I'm going to be left with cosine theta equals 5. And it says, oh, we want degrees. Well, right away, some of you, I'm sure, are saying, this is an easy one, you might as well go to the next one. Well, maybe not. Well, it says type it into your calculator. Well, if you type, you're taking the cosine inverse on both sides. Cosine inverse of that. Cosine inverse of 5. Theta has no solution. Okay? You'll see that every once in a while. So if you type it into your calculator and you get that error, there's a good chance that there is an error. Okay. Next one. So now, oh, look at this. We're back in algebra. We're just solving. That's all we're doing. So we're going to subtract 5. I think I'm going to try and get it so I can factor. Subtract 5. So I have 2x squared minus 9x minus 5 equals 0. Well, from there, oh, look at that. I have 2x plus 1 times x minus 5 equals 0. I set each of this term and this term, that's a nice different bracket, to 0 equal to 0. So I'm going to have 2x plus 1 equals 0. So x is equal to negative 1/2. And then the other one, x minus 5 equals 0. X will be equal to 5. Okay, that wasn't too bad, was it? Just a little flashback in time. Okay, now we're working with cosines again. So we're back in the trig stuff. Well, right away I see, okay, I'm going to have radians. Remember that, radians. So, I need to solve. Well, okay, I see a square term. This is just like x again. So it's like x squared minus 9x. So I'm going to try and see if I can factor. I'm going to throw that over by subtracting. So minus 5. I have 2 cosine squared t minus 9. So we're looking at 9 cosine t minus 5 equals 0. Okay, put in there. Oh, look at that. I can factor this also. I have 2 cosine t plus 1 times cosine t minus 5. So once again, you just set both these terms, this term here and this term here, to 0. So 2 cosine t plus 1 is equal to 0. So cosine t is equal to negative 1/2. And this term here, cosine t, right away I'm just going to write cosine t is equal to 5. Oh, look at that. That looks pretty familiar, doesn't it? If I go back, maybe it's oh, look at that. Cosine theta equal to 5 is no solution. So we already have one answer. So we're going to write, if I can find the right slide, right? So cosine t, so t has no soul or solution. It's not alive, so it can't have a soul, right? So now cosine t is equal to 1/2. Well, negative 1/2, sorry. Thinking about my unit circle, where is cosine negative? This way and this way. Or I should say this way, on this side, quadrant 2 and 3. Well, right away I'm thinking, okay, so negative 1/2. So this is going to be a negative 1. 2, we know that's the square root of 3 from that. That's the square root of 3. So negative 2. Okay, so we have two possibilities here and here where our function will be negative. Okay, so now we think, okay, cosine t negative 1/2. Well, 1/2 is just a 60-degree angle. So we know this is going to be a 120. Or, this is 60 because of our 1, 2, square root of 3, or our 90, 30, 60-degree angle. So we know that is going to be, so t will be equal to, we need radians again, 2 pi over 3. Well, now we need to go down here, which is another reference angle of 60, which is 4 pi over 3. Okay, so answer. So we're moving right along. Okay. Ooh, look at this quadratic formula. How many of you remember the quadratic formula? Well, let's do some fun and write it up. So we have the opposite of b plus or minus square root. Any of you sing it when you were younger? And then we have b squared minus 4ac all over 2a. Okay, I know I'm a great singer. A lot of you are like, okay, I'm going to just mute the rest of this. Please don't. So we're going to find RA, B, and C. Well, first off, is this in standard form? Yes, it is, because our largest degree is the left, the degree of this is 1. The next degree would be 0, but that's just 1. So A is 2, B is negative 4, C is 1. Okay, so all we need to do now is plug it in, plug and chug. So the opposite of B. Remember, you're using B, not just negative 4. So the opposite of B, which is the opposite of negative 4, plus or minus the square root of negative 4 squared, minus 4 times 2 times 1. That's all over, not just your underneath where your radical sign is, everything, times 2 times 2. Okay, so which that is equal to 4 plus or minus the square root of 8 all over 4, which is equal to 4 plus or minus 2 square root of 2 all over 4, which can be simplified to 2 plus or minus 1 square root of 2 all over 2. And if you want, you can break apart this. So that's going to be 1 plus or minus the square root of 2 over. And there is your answer. So what is that answer, or what is that solution? That's what X, that's what X. So you're going to have 2. You have 1 plus square root of 2 over 2 and 1 minus square root of 2 over 2. Okay, the homework is right here on the bottom of the page, so don't miss that. We'll be doing that in class tomorrow, so have a good night, and don't forget forget about writing that summary in the question.